Rational functions are defined as a quotient of two polynomials. For example, we have f of x equals p of x divided by q of x, where the denominator q of x cannot equal 0. In order to solve rational functions, we always want to try to factor the functions first. This video will take a look at how to find the domain of rational functions. To find the domain, we need to set the denominator equal to 0 and solve for x. This number is not in the domain because it makes the function undefined. We could have more than one number that is not part of the domain as well. Let's take a look at two examples here. The first example is f of x equals 3x squared plus 4x minus 1 divided by x plus 7. Notice that the numerator is a polynomial of second degree, and the denominator is also a polynomial of first degree. Now we want to figure out the domain for this rational function. So we need to set the denominator equal to 0 and solve for x. So we get x equal to -7. Now this means that -7 is not part of the domain because -7 will make the function invalid. Let me show you how it doesn't work. If I plug in -7 into the function, we get 0 here in the denominator. And we can never divide by 0 because it will make the function undefined. So we know that -7 is not part of the domain. We can think of a number line. -7 would be on the left. Positive numbers over here on the right. We have -infinity and positive infinity on both sides. And we know that -7 is not included in the domain. So we'll put an open dot at -7 and draw arrows to show that all the other numbers are included. So we have an arrow going to the left and an arrow going to the right. So that separates it into two different parts. Let's take a look at the part on the left. The interval would go from -infinity over to -7. And then we calculate the area on the right. And that arrow starts at -7. And it goes to the right to infinity. And remember that this union symbol means and. So writing the answer in interval notation, we'll have that. -7 is taken out of the domain because we have parentheses around it. Let's work another problem. Find the domain of the following function. F of x equals 3x plus 6 divided by x squared minus 5x plus 6. Now we want to try to factor the function here. In the numerator, there's 3 in common, so we'll factor out a 3. That leaves us 3 times x plus 2. And then we need to factor the denominator. We need to think about finding two numbers that multiply to 6 and add to -5. And the factors turn out to be x minus 3 and x minus 2. Now nothing cancels out here with the function. So we'll go ahead and find the domain by setting the denominator equal to 0. And then set each factor equal to 0. So we get 3 and 2 for the numbers that are not included in the domain. Now when we think about the number line, it'll be set up with infinities on both ends. We'll put 3 and 2 on the number line. And those will have open dots because they are not included. Then we need to draw arrows to highlight all the other numbers. So these numbers are valid going to the left. The numbers here in the middle are valid between 2 and 3. And then the area to the right is also valid. So the interval starting on the left side, looking at this area here, it goes from -infinity up to the open dot at 2. Then the middle portion right here is between 2 and 3. And then the area on the right is 3 to infinity. Notice that we are taking out 2 and we're taking out the number 3. So this is how we'll write the domain in interval notation.